Okay, uh, we're looking over some of the basic contracts that are part of the robot suite for the community, and uh, the robot on Discord with the R node standalone currently running on robot.net, which is a machine we manage cooperatively, which is a Ubuntu 2 1804 system. And I'm in the Vim editor here, looking at the locker contract. And the data locker is where people keep their private stuff. And the way we exchange capabilities or permissions is by sending things to the locker. And the so this contract creates a new name locker, which is a channel. A name and a channel are the same thing. And then it creates a name trace, which it associates with the special name rhoio standard error, and std out standard out, which is associated with the row ID standard out. Now, the insert arbitrary is associated with the row registry insert arbitrary. So there's a registry. Ordinarily, if I make a new name here, okay, the name is valid. I create these new names and I have a brace here, and this defines the scope. So the scope, the whole rest of the scope of this program, these names have a meaning. But as soon as I'm done executing the program, it's gone. So the registry entry, by inserting into the registry, I can a name into the registry, I can later look it up. And this is the lookup function here, which is the row registry lookup.
So basically the registry is where all the contracts are.
Well, not necessarily. Certainly the public, if you want people to be able to look them up, yes. Well, they don't have to be in the registry. For example, I could create a directory of contracts and just put the directory in the registry. And then you could look it up in the registry, in the directory, without using, look up the contracts in the directory rather than storing each one of them in the global registry. And then that way I could restrict access to the contracts to those people that could read the directory if I wanted to, or I could register in the directory. And we can look at directory contracts later if you have time, or if you want to. But I just wanted to, since this is the basic mechanism by which people can store private stuff, I just wanted to give some idea of how this was. Okay, and then
Jim, is this writing to the R store or R space in any way, or is this registry stuff related to that, or am I off key?
our space is okay. So the registry is an application. It is a standard application running on rholang, as far as I understand, and this application executes against our space, like everything else in rholang.
It's built
That
in.
that makes sense. So this is actually a rholang application that allows us to limit scope and permissions and things like that, all within rholang, but it's nothing to do with the under the covers implementation and running of rholang,
Yeah,
which is where our space would sit. Thank
right.
you for clarifying. I'm with where we are now.
Yeah,
Thank you.
the registry is built into rholang. Locker is just a mechanism that Dan created, actually, as a model of how you can store private data. And it's not really secure. It's kind of toy, okay, because you'll see that what happened here? Oh, okay, so he has a test program here first. Okay, that confused me. Most often you'll see the test programs at the end. But here, he's starting a test of the program where he sends to the locker, which is still in scope here, um, a um, a private key, which he sets up later, I guess. Oh, he's setting it up now. He gives it a private key, and he gets back a locker channel. And then he reads the locker channel to get the locker. And then then this locker he gets back, and he updates down here with this trinket that he set up, which is just the string trinket. It's just a basic test to see if he can store something in a locker. So his trinket is just the string trinket. He updates the locker with that. And if we and then he does some more testing here. I think we'll look at the program down here. Okay, this is where it does an insert arbitrary into the of the address of the locker contract into the registry and gets back a URI for that on a URI channel, and then it reads the URI channel, and then writes to the standard out the string define $locker with the URI. Okay, when robot sees that string in the log, that's when it defines locker to be this URI. Okay, so by echo $locker comes back with that URI. Okay, that's because from when I run this program. Okay, and here's where the definition of the locker contract is. And a contract is really a persistent read on this channel of, he gets a little fancy here, the name, public key, and a byte array. So this contract will only get called if you send it a byte array. And
What is a byte array?
it's like binary data.
Is it like built in rholang?
It's like it's a string, but it's a primitive type. It's really just a bunch of characters. They're bytes, and there's an array of them.
So it's like built in language type.
It's built into the language. Oops, and that's why up here, when I pass it a private key here, I called the function here hex to bytes. And that should be on the cheat sheet, which is pinned to the rholang channel. I don't even know if it has byte arrays on here. It doesn't. Huh. There's a couple of things that I think was missing here, which these are the kinds of things we want to fix if we can. Something's missing. But, yeah. Oh well, byte array is not on there. But you'll find when you're calling these internal functions, and particularly crypto functions, that you'll see byte arrays used pretty regularly.
Jim, is the and there logical and, or is it just saying? Can you hear me?
Yes.
Yeah. So it looks like a conjunction symbol, like a hat, the and sign in the middle.
Yeah.
So because you're waiting for a byte array on the right hand side, is there an operation going on there? Some sort of AND operation between the pub key and the byte array?
Well, it's a little bit funky in that, this pattern here, okay, pub key matches something, and it is also a byte array. Okay, and the name pub key gets bound to that byte array.
So is that some sort of type check, or it's forcing pub key?
Sort of a type. It's kind of a type check, and it's actually, this was from Dan's code. I wouldn't have done that here because if you pass anything else by accident, nothing will happen. Okay,
it'll be blocked.
It'll never match this. It'll never call locker if you send a string or a number or anything else except a byte array. Okay, so this, this locker function here has a return channel, or when you send it a byte array and a second argument, what it does is it's making a locker. Okay, and the locker it creates a name self, and that name it's going to use to be the contract name of the locker. And then it has an items channel where the items in the locker are kept, and a nonce channel where the nonce is kept. And the nonce is just a sequential number that is supposed to help ensure that you get sequential updates to the locker contents, I would say. I don't know. Hi, Dad Zipper, or Mom Jeff would have something else to say about that.
Hey, Jim. No, I'm just watching.
Yeah.
Not really following yet.
Who's not following?
Not Zipper, not following.
Not Zipper. Please ask questions. I guess I'm going fast here, but unless we answer all your questions, you're not going to understand it. So I would rather stick with the basics and make sure everything is understood.
So the locker concept is like something that you defined. What's the locker concept? What is about? Why it is used? What for?
Okay, the locker is used to store private stuff. Okay, this could be data. This could be contracts. It could be capabilities that you have that other people can't access.
How is it feasible in blockchain?
Well, it isn't technically because when we call this, we're going to call it with a private key. So this is a toy locker in the sense that it would be possible it's very much possible for somebody to determine to find your private key. And these are toy keys anyway. So this is, in essence, this, we're looking at part of this should be client code that isn't client code. In other words, the private key should never leave the client.
Yeah. So this is like a toy code, and the private key is inside rholang, and it should be outside.
Right.
Yeah. So I just wonder, how's I know about the unforgeable name where one who got the unforgeable name cannot construct from that channel to get data on that name. But what is locker about? How do you put some private stuff into the locker and anyone else won't get access to that stuff? how it is different from just putting stuff into an unforgeable name?
Well, the main thing is not even you can forge a name.
Yeah.
So you won't be able to get it. Um, um, yeah, I can see the issue here. Um, um, uh,
I mean, if my contract is written on blockchain and there are some unforgeable names in that rholang code, so that code can access that unforgeable names, right? And if I deploy another code with the same names for example, the same semantical names, for example, channel A, channel B, so that will be another unforgeable name and it won't access the same channel. This is like, how do we separate access from channel to channel?
well,
And from what you say, I try to understand that you can put some stuff on blockchain that you can access with your private key from any code.
yeah, and I'm the this Dan and Joshi have worked out a lot of how this is done, which unfortunately I'm not expert at, but for the purposes of okay, well, right now with the robot, the private and public key are composed by robot from your Discord identity. And it is a toy because anyone can figure it out, but I mean, you can figure it out if you look at the tuple space and you can figure out who was doing what. You can find it. For example, figure out what somebody else's private key was, and so that's not. That's something. Something we can that we have to accept at this point that this is not secure. Okay, that sending a private key. Well, okay, this sends a public key. When we create it, it sends a public key. But when we access it,
But do I understand right that locker is a stuff that allows you to access some data with your private key? So it's like a name that you can access only with your private key.
well, okay. The intention is that you're going to send some signed data to get it. That's the intention. That's why it puts the SIG here when you access it. What we have is a temporary implementation of that. Okay.
Yeah, just trying to understand what's the goal, what's the purpose of locker.
Are we saying, and I may be totally off beat here, but are we saying that the quoted keys that you set at the start? Sorry, I was going to say red, but it's not red. But at the start, you made up a password, if you like, which I guess is your private key, I think. And are we saying that the intention is that unless you pass in the correct password, you won't be able to see the things that are stored in the locker within
correct.
rholang.
That's
But
correct.
if you were, by tools I don't understand, to look down at the R space or the tuple space, then you would be able to see these private keys that we've created. Hence, it's not really secure.
Right.
Am I along the right lines there, guys?
Yes, it's on the right, along the right lines. Okay, this password-like mechanism is a stand-in for sending signed messages that only you can sign and can be shown to be you. Okay, and that capability is available now, and this contract could be, like, probably should be updated to do that, and that's one of the tasks we can do in the work study. But in the meantime, what we can do is we can store things in the locker and assume that we're going to make it secure and nobody else can access it. And in fact, there's not really no easy way for somebody to figure it out. It has security by obscurity, which is not very good. Is that clear?
Yes.
Yeah, that makes sense.
Okay, so the locker has an items channel, and you can store anything in the locker, and in principle, nobody else can see it. So if you put unforgeable names in there, you can get them out. Okay, you can't forge them, but you can store them in your locker and get them out. And this was used by Dan's original voting implementation, and with some enhancements now that include a mailbox support, it's used for the current ballot contracts. Okay, so it's going to create a locker. This is the public key. It's going to return a locker object, and the locker has these things, and then it sends to the return channel the bungle plus self. So it's sending this unforgeable name with the bungle plus. And what the bungle plus does is it makes it so you can't read it, but you can write it. So as I was saying here, the locker is equivalent to a read of this pattern. So anybody can write to the locker contract. And if it's this pattern, it's going to execute this code. But you can't read it. If you could read it, then you could change its behavior. So when somebody wrote to the locker contract, you could read it, and it wouldn't do what they expected. The bungle plus prevents that by making it write only, making the reference to it write only. Okay, so we're going to return this unforgeable name to the person, to whoever wrote to the locker contract, and now they can use that. can't forge it, obviously, but now they have it. They could store it in their locker. They could store it in a directory. They could store it in the registry. Your sound is not working, Angela.
What do you mean by unforgeable name?
Can anybody hear him?
No. Sorry, Mum Chilov. It was a little.
Or some techno.
Can we hear you now? Doesn't sound good. That's it.
Is it better?
There you go.
Okay.
Saturated.
Yes, so what do you mean by unforgeable names?
I still missed part of that. Whenever we say new and we give a list of names, that makes unforgeable names.
Why are they unforgeable?
They're unforgeable because they're private.
So if you, for example, instantiate in your contract some name, for example, called channel A, if anyone could access the channel with that name, channel A, so there will be only one channel A in the whole blockchain. So every stuff that is declared within you makes unforgeable name that is written on the blockchain as some sequence of characters, and you cannot get access to that channel through this set of characters. So if you instantiate some channel in your contract, in the code, in your deploys, only that deploy can access this channel. So does this make sense?
Yeah, it does. So it's kind of like a session.
Sorry, hard to understand. Very overloaded sound.
Yeah. Let me see. Let me see if I can run something simple.
It's kind of like a session, from my understanding.
Not really like a session, because you can always pass it around and use it indefinitely. But
you can pass this unforgeable name into another contract, for example, and that contract can use it. Yeah. But it can use it only if you send this contract from the deploy that has access to this channel.
Right. Well, let's see, this contract here, does hello world, does return hello world, does a my new channel in. Hello world, it writes new channel. That's interesting. Okay, what does this contract do?
My channel doesn't exist in this contract.
Well, it creates it here.
Oh, okay, yeah, that makes sense.
Okay, so if we do a
so this is recursive.
no, Not recursive. It defines a contract, which is where we send a return channel to the name hello world. Or, well, if we send a return channel to the name hello world, it returns hello world. So here it sends hello world to my channel, but this isn't going to really output anything, because at the end here, my channel, at this brace here, my channel is going to go away, and we're never going to be able to write it. But if we run this program now, okay, we see all kinds of stuff in our tuple space here. It's pretty busy right now. We see it was evaluated, and we see that it has no. This is what an unforgeable name looks like. But given this, you can't get the unforgeable name from this. So you can't say you can't make this up. But this will identify it for you so that you'll know which name it's using.
Basically, it's a unique ID of a channel or process, something like that.
Yeah. So this is a kind of a useless thing here, the way it is. Now, suppose in par with this, suppose we I don't know where this hello world contract came from. Suppose we make a channel called out, and we make that to be row IO STD out. Then in par with this, we write to out well, say we say for message in from my channel we out we write a message. Okay, let me
I think you're missing a character.
oh, it could be. Oops. So we look at robot.net, the R-node log, look at it chronological. Okay, we can see this is what it executed. And instead of the names we used, it just does X1, X2. So internally, the name we used is arbitrary. It doesn't actually save that name. Right. Anywhere here we gave my channel, and then we did a new hello world, and here we write to hello world, the new channel. That's how, and we can see what it evaluated this, but there was no output. Now,
Sorry, Jim. What are we looking what are we looking at there with the robot.net? Is this like an intermediate language, or I mean, it looks very similar to, or more similar perhaps to the syntax of pi calculus or rholang theory, but presumably this is on the rholang interpretation or compilation stack.
this is the same thing, the same programmer we ran.
Yeah.
Okay, it's just with the wording, the wordiness has been removed. Of course, now we added to this program. Let me run it again.
Mm-hmm.
This is just a log from the illegal character.
Yeah, you're missing a character after std out. Yeah.
Well spotted.
Can you hear me okay now?
Yes, I can. Very well.
Me too.
Okay, so now now we can see our longer program, and this time we got an output, hello world.
Nice.
Okay, so we just took an extra step rather than, so it writes hello world to my channel, and then it reads my channel and it writes it out.
Mm-hmm.
Okay.
Is this robot.net like a dev tool, or is it actually looking at code that's generated within R-chain processing?
Yeah, we're just looking directly at the R node output. So we're running R node,
Mm-hmm.
and there's an output file. R node comment out. What? Looks like a dot. Huh. I don't know why it doesn't find that out. Let me just cd ... goes back up to the parent directory. I'm in the main directory now for the R-chain account on robot.net.
Mm-hmm.
And if I do rnode.log is what I wanted, not rnode.out. So so when we run rnode, this is what we see. Okay, this is all the output from running rnode.
Oh, yeah. So this is like an R-node stack trace, and it internally it represents things as X's and Y's, and rather than semantically meaningful names.
Yeah, X0 to XN.
Yeah.
Because those names aren't saved.
Yeah. which I guess is important from a performance point of view. Well, maybe not, but it's certainly shorter, right? And it kind of looks neater in many ways. Yeah. Okay. Thank you.
Yeah, the names are arbitrary, right?
But the point is that it really is part of the processing of the R-chain network. It's not this robot.net application.
Right.
Thanks. Sorry, I know I digressed a bit there, but I think it's useful to try and understand how the processing occurs.
Yeah, there are no dumb questions.
Thank you very much.
Where were we here? We returned an unforgeable name we call self. We could have called it anything. It's actually an instance of a locker. This is sort of like the class locker, whereas what we're creating is an instance of a particular locker. Okay, and then in the items channel, we store an empty map. And you'll see the curly braces specify a map. And once again, we can see the map operations here. The map has labels with values. And we have these functions that work with maps. Empty curly braces is just an empty map. In other words, we're creating a locker. We're not putting anything in it right now. Okay, and in the nonce channel, we put in -1. Well, I guess the first nonce we're going to use is 0. So when we use it, it's going to increment whatever's in the nonce channel, and it's going to compare that against what we gave it and make sure we gave it a correct nonce. Okay, so now we're defining another contract, which again is a persistent read on the unforgeable name self, which is the locker we created. And here we're giving it a string get nonce, which is a process, a simple process in rholang. And we're saying that the name of the get nonce process, which is just a public name. Anybody can forge that. But we're putting it in the pattern of what this locker receives. So when it receives the string get nonce and a return channel and the second argument, it's going to execute this code. And this code reads the nonce channel, and then it returns the nonce. And then it writes the nonce back to the nonce channel. And this is an important concept here. When we read something from a channel, it's gone. If we want it to still be there, we have to write it back again. So when we have a variable and we read it, we have to write it so that it persists.
I think I sort of see that why you'd have to write it. That's because of the asynchronicity of the language, right, and the way it gets processed.
Yeah, the only thing you have is channels, and you can write to. When you write to the channel, it puts something on it. When you read, it gets it back again. Now, there is on the roadmap of peak operation, which doesn't actually read it. It looks to see if there's something waiting to be read, and it tells you what that is. There are certain issues with that. Peaks are kind of dangerous. This forces synchronicity. If somebody else is reading on a nonce channel when you've already read it, it's going to wait until you write something back. So it sequences things.
I think I see. Can I ask another question?
Sure.
You mentioned a couple of times across 2 sessions I've attended pattern matching with respect to the @ symbol. And I really haven't got my head around what you mean by that at all. In that I'm aware of names and processes and channels, and I'm very new to it all, but most of what you've said makes sense. But when you've used the term pattern matching, as you did a minute ago when you said contract self @ get nonce is pattern matching, in what sense is it pattern matching? Against what?
Against what's sent to the channel. If we look here at locker again, the pattern that it's reading is something that we can give the name public key, one entity that is also a byte array. That's the pattern for the first part of the tuple. Second element is another name. So if we receive a byte array and a name, we're good. Okay. Or in something else, it doesn't say what return is. Return can be anything. What we're expecting it to be is the channel that it's going to expect the value on. But there's only.
Thank you for pointing to that, because the notion of a pattern seems a bit clearer in that little example with pub key conjunction byte array than it does when you've just got a quoted string. So
yeah, and okay, we always send names, and the @ sign just transforms the process get nonce into a name.
Yep, I think that makes sense. So if it was a name and you put a star in front of it, that's the equivalent of a drop in rholang theory, I think, if I've remembered correctly.
A star is for execution, right?
Yeah, it makes it a process. It has the process associated with the name. And there's
So I guess now I can be a little more precise. Thank you for bearing with me, guys. So I kind of get the star and the @ as in converting, the @'s going from a process to a name, and the star's moving something from a name to a process. And I'm aware that in rholang, processes are our base elements, not names, unlike in the rho calculus and in the pi calculus. But I still don't really see where the pattern aspect of the of the quoting of a process. So I'm now looking at pub key conjunction byte array in the first example with the @ sign in front of it, and I'm thinking the pub key conjunction byte array is in some sense a process, and the @ sign applied to it is converting it to a name. I'm fine with that, but I don't really see how you would then say anything about pattern matching, and maybe that's what I'm missing.
Yeah, well, let's start with traditional languages, right? Where we have functions like in Java, JavaScript, or whatever, where it takes arguments. And you may have a function with one argument do one thing. A function with two arguments do a different thing.
Mm-hmm.
A function with a certain type argument could be defined to do one thing, where the same functioning with a different type argument could be defined to do something else.
Basic overloading.
That's called in Java, that's called the method signature.
Sure.
Okay, and it has to do with the type and number of arguments only.
Mm-hmm.
Okay, rholang signatures, rholang patterns are like signatures. In that, you know, the type and number of arguments can certainly be different. We could have a different locker contract for different types and numbers of arguments. Okay, but in
Now I see.
rholang, we call that the message pattern. The pattern of types and numbers of arguments, so to speak. Okay, and in this case down here, we're being very specific. We're saying, well, the first argument is the string get nonce, or the name of the string get nonce.
The literal name
The
of
literal
the string
string.
get nonce. Yeah.
Right. Okay, so so then we have another thing here with a literal string update. So that's only performed if the first argument is exactly update. And it has a second argument that's a byte array. And it has a third argument that's an int. And a fourth argument
Mm-hmm.
which is
Weird.
fourth argument, which is the more is anything, is a map. I never
That's
saw,
brilliant. Jim, thank you. So this is where your types come into the language.
yeah, but your primitive types anyway.
Okay. Thanks.
Yeah, this ... underscore means we're not, the underscore here means we're not going to bind any name to it. But we're binding a name to it here with the more. So whatever this map is that's passed to us, we're going to bind the name more to it. And then we have a fail and an ACK channel. And those correspond to trace and standard out, or whatever you called it.
I didn't quite get the ... expression. ...
means any number of. Any number of elements. So if you have a list that would have, maybe you'd have first, comma, ... more. So the first would be the first element, and more would be all the rest of them.
And the curly braces, what are the curly braces in terms of syntax? What do they mean?
Well, it depends where you are, okay? In terms of a data type, it means a map. Hey, David, you came back. So you would have, oops, I didn't mean to do that. What did I do? Holy mackerel. I think I clicked on something here. Okay, so we look at, here's a sample of a map. Has a name A with the value 1 and a name B with the value 2 in curly braces. Okay, so you could have any number of labels and values in a map. And the curly braces indicate that it's a map. If it's a set, you actually have the word set, and then you have parentheses around it.
I get the idea.
If it's a list, it has square brackets around it. Okay, and then tuples are in parentheses.
Presumably the rholang specification that Greg put together, or Greg and Mike, specifies which of these are our true primitive types in rholang and how you build these data structures. Maybe none of them are primitive in the syntax. Is that correct? So I mean, the row calculus is ultimately, and its transformation rules for processing, it is ultimately the base of the language, right? With processors as base elements.
Yeah.
And presumably out of these, you can write in rholang a set of, I'll call them contracts for want of a better word, that can then define these data structures that we're looking at. And then those data structures are usable, and all that's been pre-delivered for us by the RChain team. Is that a reasonable?
These are primitive data types. They're not written in rholang. Okay, they're primitive data types. They're essentially just represent themselves in the sense that you know, they're like equivalent to nil or zero in terms of the calculus, except that, you know, they're carried forward, so to speak. I don't know. But these, you know, they're defined in the rholang spec. Yes, they're not added onto the rholang spec.
Okay, got you. Thank you.
Well, there's, maybe you were confusing row calculus and rholang.
I think I very much. I think I
calculus, but they are part of the rholang.
Sorry, I think I was on mute. I definitely was confusing the row calculus and rholang. So they're not part of the row calculus. They would be built from that, keeping rholang pure, or would rholang have these coded in separately?
You know, if you were to implement integers and everything else in row calculus, it would be horribly inefficient.
I see. Thank you.
So, you know, it's a given that you could define these things. So, what they're really doing is they're using built-in structures of the development environment.
I've got it. Taking implementation efficiencies whilst preserving the equivalence with true row calculus.
Exactly.
Thank you.
All right. So, so the update, we can see this has a very complex pattern that it's reading. with 1, 2, 3, 4, 5, 6 arguments, a byte array, an int, a map, and then fail and act channels, which could be anything here. But obviously it would make sense to have those created. Then we
apologies, Jim. All I can see on the shared screen is my name at the moment. Is everyone else seeing the same thing, or is that just me?
I think it's just you. I can see Jim's screen. I think
No problem. Mm-hmm.
You might need to change your screen, like what you're viewing on the Zoom menu.
Okay. I think I need to learn Zoom. Please carry on, guys.
can you see the screen?
That's better. Yes, I can. Thank you.
Okay, so the get nonce, simply return the nonce and wrote it back to the channel. The update takes all this stuff, says it's going to update, reads the nonce, checks the nonce to see if it's correct, fails if it isn't, writes the nonce back to the channel. Otherwise, it says to do here the real sig checking, which we haven't done yet. This is what we talked about in the beginning, to actually verify the signature. Then it checks, so if it got, in this case, what it got was a private, the toy private key. But if it was correct, then it reads the items. Oops! It reads the items from the items channel, and it writes the items back with the union of the more, whatever was passed here as the as a map. So you can set as many values as you want with an update to a locker. It does a union operation here, which is defined, oops, I did it again. Can't click on that. Which the union is defined here, map union. Okay, and then it just sends a nil back on the act channel. Not sure why it has to send anything. Then it does is self get or a get on the locker, which again checks the nonce to see if it's correct. Checks the signature, which we want to fix at some point to be secure. And then just returns the contents of the locker. And that's the end. Okay, and then the test program was at the top here, where it sends to a locker a public key and a return channel. It returns the return channel. It stores a trinket. It creates a trinket and gets an update channel. And then it writes a byte array of signature, and supplies a 0 for the nonce. Since it's the first call to the locker, next call, use a 1. And then has a trinket, which is a pointer to the name trinket. Puts that in there. It gets back an act. And here you see the underscore means I don't need the value. I just need to know if I got it, if I received something on the act channel. He sent a nil at the end. Okay, and then we do, it does a locker get. And then he does a pattern here for receiving a trinket on the return channel from the get of the locker. If he got that, he says win, got trinket. So I was just testing to see if he can store something in the locker. And that covers the locker channel. Any last minute questions? I have to head off to another meeting. You're welcome to hang out and continue to do stuff. What I would suggest you all do, if you would, and this, well, I'll probably have to be done again because we're going to upgrade to a new R node. R node 8.4 or whatever, 0.8.4 has been released. You want to update that. But if you do a make my locker colon, it'll make a locker for you. I already have one. If someone else can go to the robot testing channel and type make my locker colon, I can do a show what make my locker does. Whoops. What did I do? I did want to do a show, didn't I?
Show make my locker.
Make my locker. Oh, I forgot the $sign. But I don't need it on. Did I spell that right? Huh. Maybe a bug in the show command. And I need a spelled that wrong. So this will show the definition of it, which dollar locker was the value that was stored. Where'd it go? Um, uh, so I can just do an echo. Locker. So this is the value that was stored when we did the define when we inserted the address of locker into the registry and we defined the locker to be a URI here. We got that value back. And so I look up the locker. I read the, this lets me get the unforgeable name of locker because I stored it in the registry. Otherwise, I couldn't get it. Found the locker. Okay, then. You find a bunch of names, and we create a new locker. And Robot supplies my public key here. So we can just put down, whoever runs this, their public key gets substituted there. And we do the hex to bytes. We find the locker. We do made locker. Okay, we then insert into the registry the locker URI channel, and then we define. Let me get rid of these guys. We do a define here. We want you guys type make my locker colon in this channel.
I can do that. So dollar make my locker.
No, make my locker colon.
Of course.
That's the robots channel, right?
I'm on the robot testing, is that correct?
Robot testing, right.
Okay. Did I do that correct?
Yeah, we'll look at a second. Then it does here, it does the standard out, define, locker. And this is concatenation, string concatenation is my username. And that's also supplied by Robot from your Discord account. So, oops, no, where is it? No, no $sign.
Ah. Oh.
Okay, we can see that it defined an address for your locker. Okay, that's really temporary also. There's no reason for anyone else to know the address of your locker, even though they can't access it without your private key.
Mm-hmm.
It accessed your locker once, so it defined the key. It defined your nonce as 1. And right now, these defines are all global. So, and then it's stored in your it looked up the value of the inbox class, which is your mailbox, got that. It did a create an inbox, which returns a set of capabilities, or a channel, and then it received, it got back a receive, a send, and a peek capability from the capability channel. And the inbox, I was hoping we would go over today, but we're going a little slow. The inbox is how we send chat messages or permissions, capabilities between each other in a secure way, assuming the locker signature is fixed to be secure. And then it defines the locker nonce, right? It updates the locker and puts in it the inbox to receive and the peek capabilities into your locker. So now so now you can get these from your locker, all of them from your locker, without looking up each of them in the registry. And you wouldn't want anybody to be able to peek or receive items in your mailbox. So you would never put that in the registry. Okay, but you do want people to send you mail. So you are going to send them we are going to have the send capability put on the registry, and we're going to define the inbox of your username to be that mailbox. So now anybody can access, anyone can access inbox rich. They want to send you mail. At this address, or they can call the thing send rich. Now let's do this way. The chat. Rich. Okay, and sent. You can do a show. I don't know. Did I forget how to do this? Oh yeah, I did forget how to do it. Okay, and we can see the send. Oh, show send. That's not what I wanted to do. Was show chat. The chat does a send, the user chat username message, and the send does a look up the inbox for the user and sends the argument list to the inbox. And if you do a peek, colon star std out. Rich.
That's me. You want me to type that?
Yep.
Uh-huh.
All right. So
So do I never see my private key, but because I'm logged into Discord as me, it's somehow correlated? Is that correct?
Yeah, it's really silly. I mean, if you look at the code of server.js, you'll see how it derives it very simply from the ID that you have on Discord.
Okay. So it's a bit of
Well,
JavaScript.
like I said, you know, at the time when Dan wrote this, the signature stuff wasn't mature. And clearly this needs to be fixed before we can.
It's proof of concept work, yeah?
Yeah, it's proof of concept.
Cool.
And we will fix it before we use the voting for anything important. It's still using the Discord identity, but I haven't quite figured that out yet. If we're using robot, I don't know if we can make it really secure. Well, there's a lot of ways to make it secure, but in any case, for a proof of concept, this is fine. Okay, so in 14 minutes, we have the start of the of Ned's RChain DF developer group in this same channel, in the same Zoom room. And I'm late for an open learning meeting, which I guess I'll drop by, although I would like a break. So I'm gonna drop off to the other meeting. I'll be back here to join Ned.
Is the Ned's meeting open for all?
Yes. Yeah, he wanted to do it. He suggested we do it in the Colab.
Okay.
So yeah, it's open. We're using this room. So feel free to hang around and wait for Ned to come back and lead the next segment. Like I said, in the meantime, I'm going to drop off because I think they're expecting me in another meeting 20 minutes ago. So
Just a quick one, Jim.
Yeah.
Generally, thank you very much for that session and the previous session. Because I've got things to do, but I'm not overly busy the next few weeks until I get a new job. So I want to spend some time actually studying rholang and videos, but I'll try and drop in when I can. But just for your information, this time probably won't work for me, but I can probably join the rholang sessions Thursday, Friday, and I'll try to perhaps join some of the 4 p.m. sessions as well. So thank you very much.
Very good. You're welcome. See you later.
Thanks again.
See ya.
All right.
I'll be here.